I think let's wait for a few minutes so others are joining. Once they come, we will start the webinar.
Okay.
Okay, just to confirm, Dr. Tariq, can you see the webinar information on the announcement on the screen?
Yes, I can see it.
Okay. Okay. And it discussed its potential applications in healthcare. RoboClinic has been tested on 2 local hospitals regarding length of stay predictions and mortality predictions of inpatients, and the results have been very promising. The webinar will be divided into 2 parts. There will be a talk of about 40 minutes on the same topic, followed by a Q&A session of 20 minutes. The attendees can ask questions in 3 ways: via the Q&A section that you can see in the toolbar. So you can put your questions in that section during the presentation, and or you can put your questions in chat or raise hand to speak out. So I will then allow at the end, if you raise your hand, so I will allow you to speak, and then you can unmute and you can raise your questions and do discussion. So now we are very excited to have Dr. Mahmood with us today to share his insights and experience on this topic. This is very important in today's world. So without further delay, let's welcome Dr. Mahmood. Okay, so Dr. Mahmood, please proceed.
Okay. Bismillah ar-Rahman ar-Rahim. Bismillah wa salatu wa salam ala Rasulillah. Thanks, Dr. Ayaz, for the introduction. And I'm very glad to present my work, which is labeled RoboClinic, Automating Machine Learning or ML for Healthcare. So I'm currently a professor at IBA Karachi, and I also head the Big Data Analytics Laboratory at the same institute. So, okay, so just a very brief introduction. So I have my PhD in machine learning from Italy, and I research in deep learning, machine learning, BI, BDA, and also data engineering. So currently my scholar count is 1301. And my primary focus is actually to solve industry problems while remaining in the academia. And that's a pretty difficult thing because the industry and the academia collaboration is not typically well defined in Pakistan. So what I do is that I develop contacts with the industry, and I try to bring problems from them into the institute, and then I solve those problems using during the course projects, research projects, and MS thesis and PhD thesis. So there is no mostly there is no financial benefit in this sort of collaboration. So we are just looking to develop prototypes and maybe develop some more products from those prototypes. So the industry is very happy to get these solutions. So I've worked in the last 10 years. I've worked with retail sector, supply chain, healthcare, also agriculture, energy, and telecommunications on different projects. So I've completed almost 40 projects in this manner while working with 3 different institutes in Pakistan. So not all of them can be considered to be like products, but all of them are projects which were completed, and some of them were handed over to the industry, and many were presented, and others were like for our own benefit. I have also the consultancy and training experience in these domains in the last 15 years. So some very brief examples. We have these 3 companies here in Pakistan. One is Dashi Foods, which is a spice supply chain. So their problem was to identify anomalous sales trends in their sales data. So we tackled that in the business intelligence course. We discovered those dips in the sales, and we discovered the reasons for those dips. And the company was also able to generate profit through analysis of the regular customer behavior. And the students were working on this discovery of this behavior. So that's one example that we did. Then we have this very huge electricity giant of Karachi, which is K Electric. And for them, what we did was we forecasted the defaulters of bill for the next month, and that was a very difficult thing to do. But we were able to do that with more than 70% accuracy on the test data over millions of customers of a particular area. So that was a very good exercise for the students. And the third thing we did was we have this insurance company here, and they were looking to develop a data governance solution because their analytics was all messed up. So we were able to design a data governance solution for them, which led them to have almost 50% increase in operational efficiency, and also obviously improved decision making. So this 15% is not the very accurate, but that's what comes from the manager side. So before I discuss RoboClinic, I would just briefly discuss this machine learning process. So in this diagram, I have listed the basic steps. I have taken this diagram from one of the research papers, which is quoted at the end. MLT here stands for the machine learning team, which is also the data science team, and MLP is a machine learning pipeline. So if you start at the left of the diagram, so the first thing that you need to have in a machine learning scenario is a problem. We just don't do machine learning for the sake of it. We must have a very concrete problem which is being faced by the business, and the solution to that problem requires you to learn a forecasting model or a predictive model. For example, you want to forecast the sales for some reason. So the business should have the mindset to solve it, and the business and the machine learning team should be ready to interact with each other. One of the problems that exists these days is that data scientists tend to work in silos. So the interaction between the business and the data science team could get limited, and that leads to a lot of problems later on. So we need to have a very thorough interactive process right at the beginning of the machine learning pipeline. The next thing is data collection, and that is primarily given by the IT department. So there might be some security concerns, and not all the data might be available. You might not get the most recent data, but you might get the data which is there maybe like 2 years ago or something like that. So there are different problems that are coming out from the IT department, and typically you have to manage this very wisely. So once you get hands on your data, the next step is to obviously clean the data, because raw data that exists with the IT department is almost always quite dirty. There might be missing values. The data is haphazard. It's all distributed over different tables. You might not know which entities you're looking for. The data might be inconsistent. There might be lots of data entry errors. So that's why you need to do cleaning, and that's almost 60% of the effort of this whole pipeline. So you need to spend a lot of time in cleaning the data and also understanding it before you go towards machine learning. And one of the things in understanding is to build statistical profiles to actually detect the anomalies and outliers in the data, because As far as machine learning is concerned, if you got outliers in your data, or you got some regular anomalies or noise in the data, that might disrupt the learning of your model and also the predictive accuracy later on. So it's very important that you identify it at this stage. Then you need to prepare your data for machine learning. And that's called mostly the transformation phase. You can also call it data labeling. So I might decide to standardize my data or discretize, change the discretization of some variables, or maybe also do some sort of specific selection based on the statistical profiles. For example, I might decide to remove the outliers or the anomalies and then go ahead with the normal data. Feature engineering is one of the most important things in machine learning, because not all the features or attributes could be important for the machine learning task. For example, if you want to predict the sales, so the sales might not have anything to do, for example, with the number of outlets you have for some reason, or the weather, for example, if you have recorded that, or your inventory stock for some particular time period, or the number of orders you gave to the manufacturing company. So there might not be a direct correlation. So not every feature is important to predict what you want to predict. So there are many feature engineering techniques which are available right now, and a clever data scientist needs to have knowledge of all those and then select the best one. After that, obviously, the best thing is to fit the model to the data. And you must keep in mind that there are now many algorithms that are there. I might say that there are at least 10 to 15 standard algorithms that could be used to learn a machine learning model. And then after learning the model, obviously you need to evaluate it. So the typical performance metrics that we have, sorry about that, are accuracy, area under the curve, precision recall, F score. So these are the typical performance measures. So you select them, as many as you want, and then obviously you need to test the model. So testing the model happens twice. So one is the testing that you do on your own computer in the background. So you divide your data into trained data and testing data, and obviously you train the model on the training data, and you test the model on the background in the test on the testing data. But there's something which is called the real-time testing. So if I have learned the model in my data science environment, so then I give the model back to the company or the client, and I ask them to test the model in real time. So they will test the model, let's say for 1 month or 2 months, and then they're going to come back to us and say, hey, it's you got a very good background testing accuracy, but the real time testing accuracy is not that good. So you need to go back and relearn your model. So that arrow that goes back from the model evaluation is because of that, because you need to visit your data again when your real-time testing fails. Similarly, at the EDA step, I have this arrow. So if you discover the anomalies and outliers, you might decide to resample your data. So you might start from the beginning again. So if you think that the real-time testing is also successful, then you can go ahead and deploy the model on some server so that the company can use it regularly. And I mean, every day or every week or whenever they want to use it. So they can use it like through a web interface. If the model is deployed on some web server, so you can access that through a website, for example. And then the other thing is to monitor the model. So I've written here that for deploying the model, you need a pipeline, because that's where the systems knowledge comes in. So typically the IT department has a control over all these servers in the company, and you need to deploy the model in one of those servers. So that's it has to become part of a system. You can't do that unless there's a pipeline. So we need some sort of a pipeline, which is typically not there. And then monitoring the model means that you learn the model on the training data, but the training data, let's say the training data was like for the last 3 years, okay. And then you use the model for 6 months, but now the customers are changing their behavior, right? So the people that are coming now, the predictions on these people is going to go down, because they are coming with a different behavior and your model is not trained on that behavior. So there is a drift of a concept that you have learned in the machine learning model that you learned in the previous two steps. So we need to adapt the model so that it keeps on learning the new customer behaviors, and then hence it keeps on updating its predictive accuracy and keeps it afloat at the same level. For example, your accuracy is supposed to keep afloat at 85% or 86%, so it should not come down. So in order to ensure that, you need to adapt for the concept drift. So we need a way to detect changes in the model, and we need a way to adapt the model on those changes. So these three steps are all a muddle, because typically what happens right now, especially in Pakistan, is that we do the initial steps till model training and model evaluation, but when we talk of real time testing and deployment and model monitoring, that does not happen that easily, because it's a difficult thing to do, which requires system knowledge. So here is a model. Now, the problems in this process, Gartner said around a couple of years back that 85% of analytics projects, which can be considered big data projects or AI projects or ML projects, they were failing. So some of them might be actual deployments, some of them might be just proof of concepts or prototypes, but they were failing. So the reasons I figured out, and what you can also search online, is that the machine learning team, they tend to work in silos, as I said recently on the last slide as well. When you don't interact with the business, because I myself have suffered a lot due to this limitation when I was a data scientist working for some industry. So this reduced interaction creates a lot of problems. And you have a tendency to output something which is absolutely not required. You might be designing very flowery dashboards, you might have very cool sale forecasts, but the business might say, oh, we this is nothing for us. I mean, this does not solve anything. And then a bigger problem is that the data scientist or the machine learning team, they take lots of assumptions while cleaning the data, while building the statistical profiles in the exploratory data analysis, while doing feature engineering, and while doing algorithm selection, for example. So they rely mostly, this could be biased because they rely mostly on their previous experience, a personal judgment about what they think is right. And nowadays, we got this chat GPT and we got this Google. So you just on the fly web searches, okay, I'm facing this problem, what should I do? I should do this, okay, let's do it. So without having any concrete knowledge, theoretical knowledge of what's going on, should I do this or not, and on what basis is the result valid for me? And then we see, okay, is this thing offered by Python, so let's use that module and do it. So we assume a machine learning pipeline, but that might not be actually what is required um, to get a sustainable machine learning model. That's the problem. And there's a reduced focus on real-time testing. So if I got a background testing of 89%, so I'm very happy, but I'm not that much bothered about the real-time testing. That's the behavior of a data scientist typically. And I'm not really that much bothered about concept drift, because that's a separate project that, oh, how can I detect drift? That requires me to have pure statistical knowledge, etc., etc., etc. So these are the problems that are facing the machine learning applications right now, due to which many projects do not achieve their final outcome. So what we need to do, we need to automate the biasness. We need to automate the steps which are creating the biasness. That's the main stuff of the presentation today, that wherever the data scientists are lacking or biasing the process, so we need to automate that to remove the bias. And obviously for that, we need a pipeline to streamline the model. We need to give equal weight to real-time testing and deployment, and we need to focus more on drift detection and obviously adaptation of the machine learning model. So for that, we take help from DevOps. So I guess some of you or all of you might be aware of this DevOps. So DevOps is primarily streamed. It's you can say it's a streamlined process for development of software and testing it and deploying it. So if you see this diagram, which I have taken from reference number 2, so you build a model. Sorry, you build a software, then you test it, and you release it immediately in a short period of time. It gets deployed, it gets into operations, it gets monitored, and then obviously something goes wrong, and you are told, the developers are told that, oh, something has gone wrong, do something. So it immediately comes back, and then you code again and you build again. So what used to happen previously was that the builders and the testers and the deployers, they were completely separate entities, and it took weeks for a model to get deployed. But due to DevOps, it has all become streamlined basically by using several softwares. So I can't go into the details, but one of them is Git. Okay, so which is able to build versions of the code, and the other one is, for example, Jenkins and the proprietary tools, which is able to coordinate between all the different entities here. And the third one is, for example, Docker, in which we use containers to actually streamline the communication between the development team and the testing team. So you give them your Dockerized platform, and they will just take the platform and test it. They don't have to design their own platform for um, testing your product or your code. Okay, so DevOps offers us, the best thing it offers is a pipeline in which I can communicate very, very quickly. So things happen very fast between the development operations. So what people did, for example, so someone in 1999, for example, I think it was at that time, someone talked about ML ops, and the word became famous. And now that's the application of DevOps to the machine learning process. And that's what I call the automation of machine learning. Okay, because things happen very fast and I can do the automation in that pipeline. So in the ML part, what I'm doing is that I want to find the best machine learning model in an unbiased way. So I will automate myself, whatever technology I want to discover. Then in the dev, I will look to deploy the model. So I need the DevOps help from DevOps to help me deploy the model. So I will take the concepts from DevOps and I will deploy the machine learning model based on those concepts. And in the ops part, I'm going to go for detecting the drift. So what that means is that, okay, I'm going to detect the changes in the model and I'm going to adapt the model. So it keeps on learning. So you can call it self-learning system. It keeps on learning and adapting itself. So that can go on for several years or for as long as the business wants. So now we come to the healthcare part. So all of us must have gone to the hospitals because all of us keep on getting sick. So typically the record of a patient is called an electronic medical record, and that's a large amount of data running into megabytes to gigabytes and even terabytes. If you have gone through a surgery or some big type of problem, so your electronic medical record can grow huge. And the machine learning targets for healthcare are primarily improved diagnosis, patient treatment, and satisfaction. That's the main focus of machine learning. And our focus in this slide is going to be on prediction of the length of stay of admitted patients. Because if you're able to predict this in a good way, then it can optimize the admissions, it can optimize the patient satisfaction to a large degree. If you're able to predict this accurately, how long you're going to stay with us. And then more important than that, the prediction of mortality for very critical patients, for example, undergoing heart surgeries for something like that, or brain hemorrhage surgeries. So prediction of mortality becomes extremely critical. So that's a serious thing. So we're going to be focusing on this one. Besides that, you can have many other applications like reducing operational costs, medical image analysis, discovery of new drugs, etc. So a lot of work has been already been done by many companies across the globe who have designed manual and tailored machine learning applications. So some of them are listed here, but there can be more because I'm not showing all these companies here. So you can see predicting blood glucose changes, stroke detection on CT scans, medical diagnostic applications, stroke detection, notification or prediction, ECG analysis. So lots of things are going on, but all of them are manual. And these tools are also all of them manual. Only the first one, it's called ClosedLoop, is the automatic machine learning tool for healthcare, and that's the only one which is available right now, to the best of my knowledge. All the other tools are very good, so but they are being used on a manual way to solve specific problems. So it's not a generic machine learning tool. For example, Path AI is just matching patients with treatment, or someone else is building patient profiles, and someone else is just offering BI dashboards. But what we are looking for is a more generic machine learning platform which can solve any machine learning problem. So closed loop is the only one. So that's going to be the focus. I'm going to talk about that later on. So over the last 3 years, we at the BDA lab, we engaged with two local hospitals. One of them is the Aga Khan University Hospital. It's accredited by JCI. It's the Pakistan's largest private medical institute and hospital. So many people are coming here from different countries and different cities to just to get treated at this hospital. And the second one is a philanthropic, initiative. It's called the Tabba Heart Institute. Tabba is the name of the guy who started it. So it's one of the most well-renowned cardiac hospitals in Pakistan, and because they give you extremely good care at an affordable price without any exaggeration. So we worked with them, or we did several projects with them over the last 2 or 3 years, in fact. And we developed solutions for both of them for length of stay prediction and mortality prediction. And from these, we were able to design the RoboClinic tool that I'm going to present today. So that's an AutoML tool. And some of the solutions, we tested RoboClinic on these two hospitals. I'm going to talk about that later on. Real-time testing is still in progress. So here is what I want to show. This is the RoboClinic stack. So there's not much connection, but I just designed it like that according to the flow. This starts from right here, the bottom left, and it ends here towards the center right through the two black circles. Okay, so I'm going to discuss this. So the first stack, RoboClinic stack 1, is for the machine learning process, automatic machine learning, and stack 2 is for detecting the concept drift or changes in the model. So and the whole process is based on DevOps. So I'm using Docker, and I'm also using Git in all these components. So that thing is not extremely well defined. I mean, I can't do that right now because that will go into the domain of big data right now. But I'm just telling you that whatever this is happening based on the Docker platform, and also using GitHub to streamline everything. Okay. So what we did in this RoboClinic was that we tried to solve the problems that I listed earlier. Okay, so one of the problem was, okay, the data science team, it does not interact that much with the business side. So this whole stack, starting from raw EMR upload all the way up to this reincarnation at the top, here what we're doing is that um, we are allowing the data scientists to interact aggressively with the user. So I will go to the next slide to detail this. So what happens in the raw EMR upload? So we require the user to upload the data, any data for machine learning, select the data. The user should identify the problem, identify the data, take it from the IT department. The data should be clean from any data entry errors, not missing values, because we will tackle the missing values ourselves autonomously, but there should not be any data entry errors. The data should be clean with respect to that. So it should be in a particular format. It should have a particular size, because we can't allow very heavy files. Otherwise, we will have to develop a big data platform. So we want the user, for example, to give us last 2 years of data or 3 years of data, and that is typically quite manageable. When the data is uploaded, so the yellow, the orange color here represents the user, where the user activity is occurring, and the green is where we are dealing. The RoboClinic does everything itself. So we check the size and the format. We detect the type of the data. We also we check the concurrence and data. We check for data entry errors. Okay, so if the size is not according to our requirements or the formats, we send it back. If we detect the data entry errors, then again we send it back, because we have an algorithm in place to detect the data entry errors or the type mismatches. You can see we can detect those. So if we are detecting something, so we give it back to the user, and the user is allowed to reload the data in case of non-compliance. So this will keep on happening until our requirements are satisfied. And when that happens, typically the data does contain missing values, and we have enough proof of that by working with several hospitals. So we designed an innovative strategy to replace the missing values. So first of all, we detect for each column how much values are missing. Then we compute the correlation of that columns with a set of other columns. And also we compute the probability density of that column in which the values are missing. Because all the numerical data typically follows a probability density. And then we employ this correlation and also this density information to impute the missing values. So general idea is that the column will behave in exactly the same way uh, with respect to the other columns, which are its neighbors, for example, as after replacing the missing values as it was behaving before replacing the missing values. So that's the crux here. And we designed this strategy because we have experimented thoroughly with this strategy over many different data sets in one of the courses. So we are able to lock this one. And then the EMR statser module basically detects the outliers and the anomalies. Okay, so the time is, I got to hurry up. So the estimate outliers and anomalies. So for that, we again take help for probability densities. And by using some innovativeness in the existing available literature or the algorithms, we uh, tell the user that we have detected anomalies or outliers in your data. Okay, so we conduct some statistical tests, and we estimate some probability densities, and using the information from these, we are able to detect the outliers, potential outliers, and we signal to the user that if you believe these are outliers, then they should be removed, because then the machine learning process is not going to work. So that's what happens. And then after that, we build a cold profile. Cold profile basically means that at this stage I'm ready for machine learning if I don't want to do any feature selection or feature engineering. And if I do feature engineering, that's, we call it a machine learning hard profile. So we have created data structures to store the data in either a cold profile or a hot profile. It depends, basically the difference is only with respect to feature selection. So so here what we did was we involved the user thoroughly in the EDA process and the data selection process. And also here we give the user the option: do you want to do feature engineering or not? Because our experience with the doctors was that they were very, very closely monitoring the features that we were using. So almost all of them wanted they were focusing more on the features. But in other projects, many people were not focused on they were only concerned with the final accuracy. We have to give the option to the user. We can't automate this. Okay. So we have designed a very innovative strategy for feature selection, in which we ask the doctors to rank the features what they believe are important. Then we use the statistical tools that are available to us to determine the ranking of the features. And then we combine the knowledge from the doctors and the knowledge from the statistical tools or algorithms to have a ranked list of features that we used for the machine learning part. So we have experimented with this strategy in the Tabba Heart Hospital, and it gave us several percentage increase in the accuracy. But that's just one experiment, so I can't generalize that right now. Then we involve the user again, because what the labels are typically specified, what you want to predict is specified by the client. Okay, but we also give some options to the user, to the client, that okay, we have identified potential labels that you would want to predict, because they got a very good correlation with the several other columns. So this could turn out to be good predictive problem. So if the user wants to take it, he can take it, otherwise he will leave it. So we typically in RoboClinic, we're applying 3 performance metrics, and then we completely go into the automation field. So what we do is that we have designed a hybrid machine learning algorithm process. So which is we are using the ensemble approach, in fact, a weighted ensemble approach, which is quite famous these days. So we have designed one such approach, using which we are always able to output the best prediction obtainable across at least 2 metrics that we are looking at. So we don't see 3, because that will be too tight. Even we could go with 1, but we try to optimize over 2. For example, either AUC or accuracy, IUC accuracy or accuracy or NF score, etc., etc. So that this is all automated, completely automated part, and the user has nothing to do with it. So this is bound to remove the bias of the user. And then obviously we are showing the prediction results on the RoboClinic's dashboard. And this dashboard is basically an automatic dashboard that is taking knowledge from the statistical data, statistical profile that we generated in the statser module. So we take some knowledge from there regarding the statistical tests to design the dashboard. So we are showing obviously the accuracy or the predictive performance, but we might also show some other charts that are like automatically designed, for example, a bar graph, because statistically it makes sense. Okay. And then we are on to RoboClinic Stack 2, in which our whole focus is to actually learn the concept drift. Whether I need to relearn the model or not, that's what I want to detect. So for that, what we did for this is the PhD work that is currently going on, but we designed the strategy. So what we did was that we used deep learning to detect this drift. So we trained the deep learning model on the data that is already with us, and then we have a strategy to detect the drift from that data. So we look at the errors that are coming out of the deep learning model, the RMSE scores, for example, and using that, we use some thresholds to detect whether the drift has occurred or not. So for example, in this diagram, so that's one of the diagrams that my student has generated. So you can see this blue dip that is going down of the accuracy that shows primarily that your accuracy goes down, so something has gone wrong, so your data has changed. Okay, so we can detect such changes. So it's a very delicate game to play, but the more we play with it, the more we get confident. So that's what we're doing right now, but the first version is quite adaptive to real world data sets. Okay. So this was the explanation for RoboClinic Stack 1 and Stack 2. And in this we have three or four components that we designed ourselves, including the feature selection algorithm, the algorithm for the selecting the algorithm for the ML algorithm selection, which is the unsolved method, and also this deep learning approach for detecting concepts. So these three things are our own intellectual property. So we did the experiments with Tabba Heart. So one of their problems was their inaccurate static estimates of the length of stay. So they were computing some statistics because they have a research wing. So they were computing some statistics to predict the length of stay, but it was not actually a prediction. It was an estimate derived from statistics. Because the problem is that if you tell the families that, okay, your patient is going to stay with us for 20 days, and the length is increasing by 5 days, so that creates a lot of financial stress for the attendants of the family. They have to arrange the money. So the LOS predictions need to be quite accurate, let's say around 85% or something like that. So as our solution, in which we experimented with our feature selection approach and also the algorithmic approach. So our model was able to generate an accuracy of 91%. We have not tested that in real time. The background testing accuracy is this one that I'm showing you, but we have to still test the system in real time. We have the data and we are doing that right now. Okay, so that is it. So we can say, okay, as compared to their static estimates, so we must have achieved maybe 10 to 15% increment in the accuracy. Okay. But the main point I want to stress here is that why RoboClinic was successful here, because it allowed us to communicate with the doctors in a very, very thorough process, which extended over 3 months. In just cleaning the data until the final feature selection before the machine learning part, it took us 3 months. There were lots of to and fro going on, and they had around 500 plus variables for this data set. And it was really a very good exercise for me, and it made me realize that we definitely need to have this interaction in place. We can't have fully automatic machine learning system. That's impossible. And the LOS prediction, okay, so I've written here prediction improved by at least 21% manually. So this is from their statistical estimate. Okay. The second problem for Tabba was basically related to mortality prediction. So that's a very critical problem. In fact, they were facing two types of mortalities. They had to predict twice. One was a prediction before going to the operation theater, and the other prediction is given while the operation is going on. So inter-op and intra-op prediction of mortality. So this was a very complicated problem, and again, we consumed 1 month in going to and fro feature selection and taking their opinion on what's going on and what should happen, what should not happen. And then typically what they do is that the Society of Thoracic Surgeons, STS, has a score which gives you the mortality in this scenario for heart patients, but it achieves a maximum accuracy of 80%, and once only. There's a lot of doubt regarding this STS score for normal usage. So that's why the hospital asked us, and we were able to achieve, after a lot of difficulty, with our algorithm, ensemble algorithm, 83% accuracy. We're trying to increase that still, but our algorithm gives us this 83%. And that's a huge improvement. So it's at least 20% improvement over the average STS score. And last, we experimented with also the Aga Khan Hospital, and what they were looking for is that the financial deviation, because when a patient gets admitted, so they have a statistical formula which tells the patients, okay, this is your expected expenditure. That is also correlated with the length of stay. So mostly their estimate were going off the mark. Okay, so we did this project, and again, in the feature selection and cleaning the data, so they had maybe around maybe 50 variables, and it took us 4 months to clean the data with their help. So we interacted a lot of them, we found out the rating of the variables, and so there was a lot of interaction that was needed until both the doctors and the team understood thoroughly what is required. And that is the missing part in machine learning, due to which the projects are failing, in my particular opinion. In any ways, so one of the algorithms, so I think logistic regression was the algorithm which turned out to be best in this case. And we are publishing these works, I can't show you any research paper right now. So achieve 20% better predictions as compared to current statistical scores. And this is the final slide. This is just a comparison of closed loop with us. So what closed loop is doing, they don't have any drift detection. I could not figure out from their manual. And what they're doing is they just take one algorithm, which is the XGBoost algorithm. So that is, in my opinion, pretty dangerous, because XGBoost is not the solution to every machine learning problem and always. Okay, so you need to have a hybrid model in place, because you can't rely on one particular thing. So they don't have this interaction with the user that we are having in RoboClinic. And their feature selection modules, I was not able to figure out whether they're doing that or not doing that, but that's not apparent. In our case, it's pretty apparent. If you want to do it, you can do it. If you don't want to do it, you can skip it. And this intermediate machine learning profiles, okay, so this is my own term. So maybe they're also having some intermediate profiles, maybe some JSON documents. So I can't really claim that this is we are better than them in this case. So I will not go for this third row. But maybe they're also doing containerization through Dockers. So, but I could not come across that. So this is what is the comparison. So there are things that they are doing, but we are not doing. So for example, they are doing natural language embeddings. We are not doing that. They are doing statistical explanations of the data. We are not giving any explanations. We are just telling about the outliers. We are not generating any text. Okay. So, with that, I come to the end of my presentation. So if you have any questions, kindly ask. Thanks.
And thank you very much, Dr. Tariq. It was a really nice presentation, and good to hear about this specific tool, RoboClinic. So I have seen there are some questions in the Q&A section. So let me speak out this question. So someone asked about that how frequent should we check for concept drift? So it is related to concept drift. So I want to know that how frequent should we check for concept drift?
Yeah, that's a good question. It depends on the velocity of the data. So if you have a high velocity data, then you should check for concept drift like every week. So if you're talking about e-commerce data, so you should start checking like maybe it's every week, I might say, or at the most you can wait 2 weeks and then start checking, because what we are just checking the model here. We are not updating it. We will only update it if the drift is detected. So there's no harm in checking it earlier. If you don't have a high velocity data, if you have the regular customers coming in your superstores or outlets, for example, then you can check it for like, you can start checking after like 1 month. So once a month you can check it. And I think that should be it.
Okay. Thank you. So we have another question that raised hand from Tahir Sayyed. So let me unmute him. So Tahir, please proceed with your question.
Yeah, assalamu alaikum. Professor, I believe, could you shed some light on the evolution of the term AutoML across the decade, because the first time I saw this term was in a NICML workshop when I was attending in 2015. And at that point in time, they were the only thing that AutoML addressed was cross validation, and therefore setting your hyperparameters of the model. Um, could you sort of, I mean, I haven't followed through with this research over the years. So since so how well does that initial concept sort of integrate into the whole MLOps cycle? Something could I have a fairly generic comment on that? Thank you very much.
Thanks, Dr. Tahir. Um, I'm I have not AutoML has not been my research domain precisely. So I'm more towards ML ops since some recent time, you can say. So what I discovered was that we are currently doing a literature review on ML ops. So what I discovered was that in the last 5 years, there have been lots of master's thesis and lots of research papers, not lots of research papers, but several concrete research papers that have started summarizing what MLOps is doing, and they started to propose how machine learning could be applied to the DevOps cycle. So in my personal opinion, because my requirement was stemming from what was happening in the hospitals and how to address those problems. So purely from a data science perspective, I figured that we need to automate these 3 or 4 things. Okay. And then I came to MLOps. Okay, MLOps can help me do that. So I determined the automation part myself. And then I went towards automation tools. So you're right, 2015 is fine because we got things like Tpot and auto sk learn, and there might be like lazy predict libraries which are used for, you can use them for automating your machine learning pipeline. But what we're talking about here is a whole pipeline which starting from the model development all the way up to deployment and detecting the concept drift. Okay, so for that we must require the help of MLOps, and the MLOps field is taking up in the since the last you can say 4 or 5 years. So there is being work done here. So what people are doing generally is that people are proposing um, different ways of automating some modules of machine learning. So they're trying to create research from by proposing different frameworks, and most of it is geared towards the industry. So the few theses I saw were actually conducted by the industry itself. So the master student went to the industry, they conducted that. So it was more of a survey topic. Okay, what's happening? What are the technologies that are there? And what potentially we could do. And in the end, what the student did was that he or she proposed another model. For example, okay, how to couple up cross validation, a module for cross validation and a module for testing or training, and how to combine these two in an innovative way, so that that becomes a research. Okay, so but there only the cloud based companies like Amazon and Azure, they have developed complete MLOps pipelines because they got the people to do that, right? So they're deployed solutions. But I mean, we are looking in on a more research perspective and also industry perspective, because everyone is not going to go directly to ML ops, because first of all, it's very hard to understand what's going on. So you need to have very good knowledge of the system side as well to have an ML ops pipeline. So the aim of this work is actually not exactly related to enhancing the state of the art of automatic machine learning, although it does that. But my focus, as I said right at the beginning of the slide, is that I tend to solve industrial problems. So I see that the industry data scientists are doing these mistakes, and to address those mistakes we can automate that, and for that we go towards ML ops. So yeah, the field is the enhancing since the last 5 years. And I might add that most of the work is industrial and useful. So it's not like, okay, I will do that only for the sake of a research paper. So I found substantial evidence that the industry is interested also in research in this topic. Yeah.
Okay, thank you, Dr. Tariq, for very detailed answer for the questions. Okay, and I take another question from the Q&A section. Then I will come again for those who raise their hands. So in the Q&A, I have another question is related to transfer learning. So we want to know in which phase can we incorporate transfer learning, in these steps.
Yeah. Transfer learning look, yeah, so one of the things that Tahir was asking the question, Mr. Tahir, Dr. Tahir, so one of the things that people are doing is they're working on the metadata part of the MLOps pipeline. So they're designing frameworks to store the metadata. Okay, so when we talk of transfer learning, it's more like we have a pre-learned deep learning model, and we can use that to in our deep learning model, we can use that to instead of learning the model ourselves, so you can use a pre-learned model and for our own benefit. In this case, if we are using autoencoders for concept drift detection, then we can do transfer learning with respect to a particular industrial problem. For example, if you're looking for inventory optimization, so that is one specific problem in which the data is going to be consistent across all the possible industries, then it will make sense that, okay, I can use a model, transfer learning mod. I can do transfer learning of some other model of inventory optimization and use that as my autoencoder. But as far as machine learning is concerned, machine learning is a very personalized sort of thing. For each data set is completely unique. Okay, so for me, I think it will be very difficult to say that, okay, if XGBoost is working with industry A, then XGBoost will also work with industry B. There is no way anyone can guarantee that. So it's very hard to do transfer learning in this case. But what can be done is that if we are recording the metadata of what is going on, like data about data, okay, I did this, the accuracy was like that, I did this, accuracy like that. Okay, so I'm monitoring the model since the last 5 weeks, and this has been happening. If we could somehow use that metadata in some way to make our accuracy better over time, that is a very concrete research problem. So that's not exactly transfer learning, but that is something that could be a very interesting problem. So I will not I will say that currently I don't see you can do transfer learning for a research problem in the autoencoders that I have told you, but that might not be relevant if the model is deployed in the industry. For a research problem, everything is good because you can try out different things, but for an industrial deployment, that might not be the right thing to do.
Okay. So next we have Saddam. So Dr. Saddam, let me allow you to talk so you can raise your question.
بسم الله الرحمن الرحيم. السلام عليكم. Dr. Yaz, can you hear me?
Yes.
Yes, Saddam.
Wa alaikum salam.
Thank you, Dr. Tariq and Dr. Yaz, for this seminar. And thank you for your nice presentation. Regarding my question is regarding to the previous slide, the comparison table. Can you please go to this slide?
Yeah, here.
Okay. What do you mean here by natural language embeddings as an additional feature for closed loop? And how it can be utilized?
Yeah, here what they were doing is that when you like you have these physician notes, the doctor are writing notes. So the guys who work with NLP and text analytics, so what they want to do is they want to take the notes of the doctors or the physicians or the nurses, and they want to digitize that data and discover like similar patterns in those notes, some sort of homogeneity in what the doctor has written, so that we can categorize those data according to some disease, according to some treatment method, according to some surgery method. So that goes into the domain of this text analytics and natural language embeddings. So closed loop, they have designed and implemented a separate module which does that for the doctors, because that is one of the major problems that is being done right now by text analysts. And even one of my colleagues is also doing that with another hospital, which is the Indus Hospital. So they have the physician notes, and they are digitizing those notes, and then they are discovering this embedding mean basically that you convert the data to some other format. But what they're doing is that they are discovering commonalities in what the doctor has written to categorize the data, and then they will use that categorization, for example, to give some deep learning model, for example, a recurrent neural network, and make some prediction about the disease or the state of the patient, or the prescription that you need to give to the patient, for example. That's what they're doing.
Okay, thank you. Thank you very much.
Okay.
Okay, I think we don't have more questions now. Okay,
Okay.
thank you. At the end, thank you, Dr. Tariq, to give a very insightful webinar on the topic of autonomous machine learning. And hopefully it will be very beneficial for all of us, and looking forward to hear more about from you in the future, inshallah.
Thanks a lot.
Thank you.
Assalamu alaikum.